Hi kids, we'll be going with this unit 2 paper discussion. You can look at the first question. The first question says, figure shows a box B of mass m held fixed at a large height, which is very large in comparison to the dimensions of the box, but very small in comparison to the radius. So the meaning is acceleration due to gravity is g, but it takes long enough time to hit. A particle P whose mass is equals to mass of the box is suspended at O, which is the center of mass of the box, with a massless string. Particle can swing in vertical plane without colliding the box. The particle is pulled aside to horizontal position and released. The box is held fixed till the particle reaches the bottommost point. So box is held fixed and you are leaving this. So it is going to convert its potential energy into kinetic energy. After that, you are leaving the box also. So the entire system will be accelerated downwards with g, and something is going to happen. Now, at the moment of leaving the box, velocity will be root 2 gl for this. Center of mass of the box will be at rest momentarily, and there will be weight and tension acting on this force wise. So weight and tension acting on the box force wise. That's how it is going to look from center of mass frame. So in ground frame, if you observe it from center of mass frame, that is some frame which is having velocity of center of mass and acceleration of center of mass. Acceleration of center of mass is g, velocity of center of mass is m1 v1 plus m2 v2 by 2m or m1 plus m2. So when you observe from this frame, you will be feeling this velocity and this velocity will be root gl by 2. And so in center of mass frame, obviously center of mass will be at rest. And acceleration, now as it is accelerating frame, so there will be pseudo force coming into picture which will cancel these two real forces. That's the reason I didn't put anything. Now in center of mass frame, it looks like only these forces are there. So velocities for like this, so it will be rotating. So this box center of mass will be rotating with radius L by 2. This point mass will be rotating about center of mass with radius L by 2. So if I want to find tension, I can write net force towards the center equals to m omega square r or mv square by r. So for this point, if I write net force towards the center, that equals to mv square by r, radius is L by 2. From there you will be getting tension is mg. At any moment it is mg only, because in future it is going to look like rotating in center of mass frame. So equation is going to look same in center of mass frame at any time later on. So initial acceleration of the particle, tension is mg. If tension is mg, these two forces are going to get balanced at this moment. So acceleration initially is 0. Then we need to calculate omega. So you can calculate omega. If you take about center of mass, it is rotating with omega. Omega into L by 2 will give us this velocity. From there you will be getting omega value. Once you get omega value, after time t, how much is the angle rotated? There is no angular acceleration. So theta will be omega into t. Omega into t, omega value we figured out, t they have given in the question. When you calculate, it turns out to be pi. It turns out to be pi. The meaning is about center of mass, this point would have rotated by pi angle and this O would have rotated by angle pi. So this O would have been having a velocity root gl by 2 in this direction. So then they were asking speed of the box at this much time. At this much time it would have rotated by this much angle. Now not only that, center of mass frame, initially velocity is only in the horizontal direction, but acceleration is there in the vertical direction. So in that much time it would have accelerated downwards. So if I want to calculate what is the velocity of center of mass, it is going to be this much after that time. So now if you want to calculate what is the velocity of the point, it is going to be velocity of center of mass and velocity about center of mass. Velocity of center of mass is already root gl by 2. Yeah, so they were asking about speed of the box. So velocity of center of mass is already this much, and with the time it will be increasing this much. So this total thing is velocity of center of mass at that time. Now velocity about center of mass, there should be a minus sign here. So both the places there should be a minus sign by taking this as positive x-axis, this as negative x-axis. Yeah, so there will be minus I cap here, This is velocity of center of mass, this is velocity with respect to center of mass. Then it's only vector addition, you need only magnitude, right? Going to the next question, a particle is taken to a distance r greater than the radius of the earth, and r is the radius of the earth. It is given a velocity v which is perpendicular to r, and match the following assuming it does not collide with the earth. Mass of the particle is negligible in compared to the mass of the Now orbital velocity, escape velocity lies between escape velocity to orbital velocity. So in this case it will be bound, in this case it will be parabolic, in this case it will be ellipse, in this case also it will be ellipse. Anyway, you will be aware of all these things. So from a distance r, if you throw with orbital velocity exactly perpendicular, then it is going to be circle. If it is slightly less, then it is going to be ellipse. If it is less, it is going to be ellipse. If it is going to be more, it is going to be ellipse like this. Now in this case you can see in the first case where it is orbital velocity, the distance of point mass from the center remains constant. So for P it is going to be 4, and for Q where it is escape velocity distance from the mass, it is going to be parabolic path, it will be distance will be keeping on increasing. So 4 and 3. So I think in the next options they were talking about what will happen. It is going from here to here, so the distance between these two is decreasing first then increasing. Here it is increasing first then decreasing. I think that is what they mean. Consider a planet of mass m and radius are as shown in the figure. A particle is projected from the surface of the planet at an angle theta from the radial direction with velocity equals to orbital velocity of circular orbit at that point. So velocity is root of gm by r. So then they were asking couple of questions. So you can say about this point, initially angular momentum is this much, where velocity is this much, and initially energy is, potential energy is this much, kinetic energy is this much, total energy is this much. From there you will understand it is bounded elliptical orbit where the major axis is 2r length. Now it is going to be ellipse, something like this. So if you want to find what are the extreme distances, you can do energy conservation. Potential energy at the extreme point and kinetic energy at the extreme point, you can always write it as L square by 2mr square. L square I borrowed from here. That equals to total energy. Total energy is this much. Now when you solve for it, there will be two roots for r. One is nearest point, one is farthest point. When you solve for it, you will get nearest point is r minus r cos theta, farthest point is r plus r cos theta. Sorry, this figure was wrong. This figure is wrong, so you just neglect that. This length is going to be r minus r cos theta and this length is going to be r plus r cos theta, only that much you can figure out. Anyway, so if they ask about time, the time obviously depends on the area obviously depends on the theta. So, but they said in the options it doesn't depend on theta, so you won't be getting any of them. But if you want to calculate what is the time period of the total ellipse, you can easily calculate because you know what is the length of major axis. Match the entries in column 1 with the results. In the horizontal plane, no object is hinged, J is impulse of an impulsive force. Initially the system is at rest, change in some quantities. So all the questions were straightforward here. So in this case, does translation occur? Yes, obviously there is impulse, so center of mass will be moving, and apart from that rotation occurs. Now torque, taking torque about any point will be difficult, so we take torque about center of mass because torque due to pseudo force we can avoid. So when you take torque about center of mass, torque due to pseudo force you can avoid, and torque due to this impulse is there. So there will be angular impulse which will be rotating. So rotation occurs. Angular momentum about center, there is angular impulse, so angular momentum increases. Linear momentum increases, there is external impulse, so velocity of center of mass increases. So linear momentum increases. Angular momentum will be conserved about more than one point in space. If you take any point along this line, then torque because of this force is going to be 0. So angular momentum of the system will be conserved about any point along this line. So that's also correct. Similarly, going to the next case, there is impulsive force, so center of mass will move, and when you take torque about center of mass, torque is there, so it will rotate also, and angular momentum increases also. Because of this, linear momentum increases, and about any point along this line, angular momentum will be conserved. Similarly here, there is impulse, so velocity will be there, linear momentum increases, but torque about center of mass is going to be 0, so it is not going to rotate, so angular momentum is going to remain same, and about any point along this line, angular momentum will be conserved. Again, impulse is there, center of mass will move, about center of mass there is torque, so it is going to rotate also, so angular momentum increases, linear momentum also increases. About any point along this line, angular momentum will be conserved. In the following question, column 1 represents uniform round bodies of weight W and radius R kept on a horizontal surface. Column 2 represents the horizontal force F0 acting in the x direction on the body, and column 3 represents the value of coefficient of friction between the body and the surface. So you have this question, friction direction you need to calculate. So if I go with the options, the first option says 4 is hollow sphere, and 2, that is R above the center, so at the topmost point if you are applying a force. So let me say friction is not there. If friction is not there, I can write F equals to ma, and I can write torque equals to I alpha from center of mass, where torque due to pseudo force is going to become 0. From there you will get A is this much, R alpha is this much. So this bottommost point acceleration is going to be acceleration of center of mass and acceleration about center of mass. Acceleration about center of mass is more, so the bottommost point's tendency is going to be this way. So if I switch on friction, friction is going to come in this direction. Now, as it is single correct, you need to convince yourself remaining all are not correct. In the second option, it is 3P. That was solid sphere and line force is passing through the center. So I can write F equals to ma, torque equals to I alpha. You can clearly see there is only acceleration of center of mass, so the bottommost point is going to go this way. So if I switch on friction, friction will try to come this way, oppose the relative motion. The same is going to happen for the next case also. In the last case, you are applying force at a distance r/2 for a disc. So when you write F equals to ma and torque equals to I alpha, you can see A and R alpha are same. The meaning is the bottommost point acceleration is 0. So here friction is not needed for it to be pure rolling. Without friction itself, it is in pure rolling. A bullet of mass m traveling horizontally with speed u strikes the wooden block of mass m placed on smooth horizontal plane. The penetration is assumed uniform, and bullet comes to rest with respect to block after penetrating a distance d into the block. Now you should understand, by the time it traveled a distance d into the block, these two things would have moved ahead also. So with respect to ground, this is going to travel more than d. So this option is going to be wrong. Then they were asking couple of options. Block moves less distance than bullet with respect to ground. That's obviously wrong, because both are going to go ahead, and with respect to block, bullet is penetrating a extra distance d. So the meaning is bullet is going to travel d distance extra more than block. So option D is wrong, and option C is also going to be wrong. I mean, not equal to. So yeah, so that option was less than D, but we know it should be more than D. So option C is correct, and option D is also correct. Block moves less distance, bullet moves more distance, block moves less distances. So now coming to the option A, ultimately the total loss in kinetic energy, it is perfectly inelastic collision. So kinetic energy loss is going to be half into mu into V relative square, or that is the kinetic energy in center of mass frame, which is going to go as heat. Then the value of resistance force offered by the wood. So you can see, once it enters, now you can see like there will be action and reaction force. That is the reason its velocity is reducing, its velocity is increasing. So they said it is uniform. So acceleration of this is going to be F by m in this direction, acceleration of this is going to be F by m in this direction. So relative acceleration is going to be F by small m plus F by capital M. Then you can use relative motion. Relative velocity initially is u, finally is going to be 0, and the distance relative is d. So you can use v square minus u square equals to 2as. 2n identical cubical blocks are placed on a straight line on a horizontal smooth surface. The separation between two consecutive blocks is same. The odd number of blocks are given velocity to the right, whereas even were given velocity to the left. All collisions are perfectly elastic. So identical blocks and perfectly elastic. So when they hit, they are going to exchange their velocities. Now exchanging their velocities is going to be similar to one passing through the another. That you would have understood from the class, or you can look into these examples if you didn't pay attention in the class. So it looks like they will be passing through each other. So now if you notice this odd number stuff and even number stuff, they will be simply passing through each other. So you can visualize it like this 1 and 2 will pass through each other. So basically this green color things will be going with constant speed, and this yellow color things will be moving with constant speed. So if I talk about 1, 2 will pass through 1. After some time, 4 will pass through 3 as well as 1, and so on. So basically, if I talk about 1, this thing, all 2, 4, 6, 8, all will be passing through 1. So there are n blocks will be passing through 1, but through 3, this won't be passing, so the remaining will be n minus 1 blocks will be passing. Similarly, through 5, there will be n minus 2. So through the last odd number block, there is only one thing which is going to pass through. So the number of collisions are n, n minus 1, n minus 2. You need to add all of them. That is going to be n into n plus 1 by 2. Anyway, you could have guessed by taking n equals to 0, 1, 2, and you can convince yourself B and C won't be the answers. And velocity of center of mass of the entire system after all the collisions will be 0. Not only after all the collisions, at any time the center of mass of the system is going to be 0, because net momentum is 0. Imagine a hole drilled along the radius of the earth. A uniform rod of length is equals to radius of the earth is inserted into the hole. Choose the correct statements. So they were talking about center of gravity. Before going to center of gravity, the value of g at a distance x is going to be this much, that you will be knowing from the class itself. That is g m by capital R cube into small r, right? Now center of gravity, if you want to find, that depends on the definition. We will be going with our definition. I think according to the solution, they were taking the definition as this thing. This is weighted average kind of thing. So if I take this as literal definition, and if I try to implement it here, so if it was center of mass, we would have taken x dm integration equals to x of center of mass into dm integral. But if it is center of gravity, instead of mass, we will be taking weight. Instead of mass, we will be taking weight. If it is center of mass, we will take x dm and this one dm. If in case of weight, we will be taking this is x dw and this is dw. Now weight of any small element is going to be mass of that element into gravitational force there. Gravitational force there is gm by r cube into x. That I am calling it as some constant. Similarly, the same thing here. This one I can put it here. Then I have to integrate. From there I will be getting center of gravity is at a distance 2r by 3, which is not at the midpoint. So center of mass and center of gravity won't be coinciding here. A solid ball of mass m and radius r is rolling without slipping on a flat horizontal surface at an initial angular velocity omega naught. It hits a small bump of height h. Assume that the ball pivots about the tip of the bump during and after impact. Which of the following statements are true? So you need to calculate what is the angular velocity and what is the minimum angular velocity such that it can climb. And okay, only during impact, gravitational force is considered to be impulsive. No, gravitational force is finite force. Any finite force acting for a small amount of time is not going to change the momentum or angular momentum of the system significantly. So gravitational force is non-impulsive. So as gravitational force is non-impulsive, but there is normal and friction going to come into picture here. So if you try to take torque about this point, then you can do angular momentum conservation, because torque due to all the forces about this point is 0. Though gravity is there, we are not bothered about it because it is non-impulsive. So initial angular momentum about this point is angular momentum of center of mass, where this distance is r minus h into m into v naught. And angular momentum about center of mass is ic into omega naught. Both are in the same direction. And as it is pure rolling before, the relation between v and omega, v naught and omega naught is this much. This is the initial angular momentum. Now once it starts rotating, you can say it is purely rotating about this point. So you can simply say I about this axis into omega, or you can say again off center of mass and about center of mass. Eventually it turns out to be this much. This is the angular momentum of the system about this point before hitting. This is after hitting. From there you will be getting final omega. Now it has some kinetic energy. Will that kinetic energy be sufficient? If the kinetic energy is sufficient for it to climb, to increase its potential energy. If it climbs, then the increment in potential energy is mgh. If the kinetic energy available initially, that is half into I about this axis into omega square, if that is sufficient enough to increase the potential energy, then that's the answer. Omega value we know, so you will be just substituting it and you will be getting the required answer. A uniform rod of mass m and length L lies on a horizontal frictionless table. A particle of same mass moving with speed v naught sticks to the end, and force exerted by the particle, acceleration of point b. In the frame of center of mass, path of the center of the rod is circle, actual path of the center of the rod is cycloid. So you can see they were talking about force and acceleration. So in any inertial frame it should look same. So instead of observing from ground frame, I will be observing from center of mass frame. In center of mass frame, the scenario is going to be like this, where the center of mass of the system is going to be stationary. So, and I can do conservation of momentum, conservation of angular momentum. So I understand after hitting this is not going to move, and the initial angular momentum of the system should be equal to final angular momentum of the system. As it is rotating about this axis, I can go with I about this axis into omega. This is moment of inertia of the rod about this axis, and this is moment of inertia of the particle. From there you will be getting omega value. Then they were asking what is the force exerted by the particle on the rod or by the rod on the particle. So particle is going to perform, now once it hits, everything is going to rotate about this axis. So this is going to perform circular motion of radius L by 4. So m omega square L by 4 will be the force acting on the particle. Omega value we already got from here. When you substitute, you will be getting this is the force. Now they were asking what is the acceleration of this point. Acceleration of this point is going to be omega, it is going to perform circular motion of radius 3L by 4. So its acceleration is omega square 3L by 4. Now we did acceleration in center of mass frame, but you should understand it should be same in ground frame also, because both are inertial frames. So in the frame of center of mass, center of the rod is going to perform circular motion. Now center of the rod is going to perform circular motion in center of mass frame, but in ground frame basically it is going to perform circle. Apart from performing circular motion, it will be moving in this direction with a velocity v0 by 2. So it is going to perform circular motion and it is going to move in this direction with a velocity v0 by 2. So it is not, I mean, that depends on the definition of cycloid. So generally we say cycloid definition is if something is pure rolling, the motion of the bottommost point, the path of the point on the circumference is called as cycloid. But according to this question, it can be, I think they are taking the definition of cycloid as any point is going to perform some kind of curve, which they are still calling it as cycloid. Because V should be equals to r omega, I think here it won't be equals to, because you are getting some bad values with omega. And a particle of mass m is suspended from a point O and undergoes circular motion in horizontal plane as a conical pendulum as shown. Angular momentum of the particle about point of suspension does not remain constant. That you should understand. One way of understanding it is torque due to tension is going to be 0, but torque due to mg is not going to be 0. But about C, when you see, now net force in this direction is 0, so torque because of this tension component and this tension component will be, I mean, this mg is going to get cancelled and this tension component will be passing through center, so angular momentum will be conserved about C. Some people are going to do it this way. So if you take angular momentum about O, then its velocity, if its velocity is this way, then r bar cross mv bar angular momentum is going to be this way. Angular momentum is going to be this way about this point, but about this point it is going to be r bar cross mv bar, which is in this direction. Now when it is here, about this point angular momentum is r bar cross mv bar, which is this way. About this point r bar cross mv bar, which is this way. So about this point angular momentum is always in this direction. About this point angular momentum initially is this way, later on it is this way. So you can see it is changing its direction, or the other way of saying it is its horizontal component is going to change, its vertical component is going to remain same. Angular momentum of particle about point of suspension does not remain constant. That is correct. Its horizontal component, radial component is going to change. Angular momentum of the particle about center of circle remains constant. Angular momentum is in this direction. Average force during half rotation. So you need to calculate change in momentum and you should divide with time. Average torque about axis OC. The meaning is they were asking what is the change in angular momentum along this direction and divide with the time. There is no angular momentum change in this direction. So average torque along that axis is going to be 0. If you want to calculate average force, change in momentum by time taken. Now you want to get some values here. For that you will be taking help of T cos theta is balancing mg, T sin theta is providing required centripetal. From there you will be getting omega value. You can substitute that omega value to get the required answer. A uniform solid cone of height h, semi-vertex angle alpha is inclined against vertical axis as shown in the figure. The cone rotates about its own axis as well as rotates about the vertical axis, about its own axis and about the vertical axis. if the cone does not slip at point B, so this point's velocity is 0, and you can see this point's velocity is also 0. So if you know 2 points on the rigid body whose velocity is 0, you join them, you are going to get instantaneous axis. You join them, you are going to get instantaneous axis. So I can say like this entire cone is rotating about this axis with some omega, which is the resultant of these two. So you can see this omega 2 is in this direction, this omega 1 is in this direction. So once I know net omega is in this direction, I can take this as my x-axis and this as my y-axis, and I can resolve all the omega vectors. So omega vector in this direction is omega 1 sine alpha, omega 2 sine alpha. They will be getting cancelled. So omega 1 should be equals to omega 2 for that to happen, because we know net omega is in this direction. So this omega is omega 1 cos alpha plus omega 2 cos alpha. Now if you want to find velocity of this point, you know instantaneous axis, so you need to find the perpendicular distance. Perpendicular distance times of omega will be velocity of that point. If you want to find perpendicular distance, this is 90, so this is alpha, so this is 90 minus alpha, this is h given. So this is h cos alpha, this is h sin alpha. Once you know perpendicular distance into omega will give you velocity of c. And that omega we already know from here. Two homogeneous spheres of mass 1 kg and radius 10 cm are released from the same height on an inclined plane of inclination 37 degrees. Coefficient of friction of the first sphere is 0.1 and for the second is 0.3. So first of all, we should understand whether it will be pure rolling or not. So if it is pure rolling, then if I write F equals to ma, equation is going to look like this. If I write torque equals to I alpha about center of mass, it is going to look like this. And if I use pure rolling constant, A equals to R alpha. Now these are the three equations. Then when I try to solve it, I'll be getting the friction needed is this much. But normal is going to be mg cos theta and friction needed is this much. So maximum friction is mu into n. That should be greater than or equals to whatever is needed. That is going to happen only when mu value is greater than 0.21. But in the question, only one of the coefficient of friction is greater than 0.2. So one is going to be pure rolling, one is going to be slipping. So the first case is going to be slipping, the second case is going to be pure rolling. Now if it is pure rolling case, you can get the acceleration this way itself, or some people will be remembering the result also, g sin theta by 1 plus beta. So this is the acceleration in case of pure rolling, where mu value doesn't play much role. When it is slipping, when you write F equals to ma, friction is going to be maximum. In this case, friction is not maximum. Friction is going to be maximum. Then you got accelerations. Once you got accelerations, then you can use S equals to ut plus half at square to find what is the ratio of the times to cover the same distance. Or you can use v square minus u square equals to 2as to find what are their speeds when they cover the same distance. Now I don't have to do option D, because if you substitute r omega, v equals to r omega, option D will turn out to be correct, but v is not equals to r omega in this case. In this case v equals to r omega, but in this case v is not equals to r omega. So option D, I don't have to calculate, I can say it is wrong. A long thin carpet laid on the floor. One end of the carpet is bent back and being pulled backwards with a constant unit velocity just above the part of the carpet which is still at rest on the floor. What is the minimum force needed to pull the moving part if the carpet has unit length and unit mass? So this is the scenario at any random situation when this end has traveled a distance x. So dx by dt is, or x is varying at a rate 1, dx by dt is 1. But you can see when this end has traveled a distance x, only x by 2 of this carpet has come here. Now in the next moment, this carpet length is going to slightly increase. Now what is the momentum of this system? Momentum of that system is mass of that system lambda into x by 2 into v. Now in later moment it is going to increase because x is going to increase. This length is going to increase. So I want to see what is the rate of change of momentum of the system. Rate of change of momentum of the system dx by dt is nothing but v. Rate of change of momentum of the system is the external force acting on it. So if we neglect friction forces acting, so you can say the entire force is provided by S, which is lambda v square by 2. Lambda was given 1, v is also given 1. Right. So there is explanation PDF, if you want you can read. Two men of mass 60 kg and 80 kg stand on the plank of mass 20 kg. Both of them can jump with a velocity 1 meter per second relative to the plank. In each event shown in list 1, find the velocity of the plank after the event. Initially the system is at rest. So they said in the first case Ram will jump with speed 1 relative to the cart. So if cart has a velocity v, then this guy will be having velocity of the cart and velocity with respect to cart. This guy will be having velocity of the cart. Now if you do momentum conservation, right side momentum should be equals to left side momentum. You will be getting the answer. So similarly in the next case also, when this guy jumps, he will be having velocity of the cart and velocity with respect to the cart. Again, when you do momentum conservation, you will be getting the answer. And I already assumed the direction is this way, so and we got positive value, the meaning is it is correct. So its velocity is going to be in the negative direction. Now similarly, this guy is jumping, this guy is jumping. I assumed cart is moving this way because I know, because if this guy's momentum is 80, this guy's momentum is 60, if v is 0. So net momentum is in that direction, which can't happen. So there should be extra momentum in this direction. So velocity of the cart, velocity with respect to cart, velocity of the cart, velocity with respect to cart. Again momentum conservation, you will be getting answer. Now they said in the last question, from this scenario again he is jumping. So if I take this scenario and if I observe from a frame which is moving with 3/8 units, then they will be stationary. They will be stationary. Now when he jumps, again I can do momentum conservation in this frame. When I do momentum conservation, I will be getting 4/5 in this direction. So this has a velocity 4/5 in this direction when I observe from this frame. So if I want to find the actual velocity is going to be 3/8 minus 4/5, because 3/8 is in this direction, 4/5 is in this direction, which is going to be 17/40 in this direction. The minimum and maximum distances of satellite from the center of the earth are 2r and 4r respectively, where r is the radius of the earth and m is the mass of the earth. The minimum speed of the satellite is, minimum speed of the satellite is going to happen here, that you know, and total energy depends on the total major axis. So total energy is minus gm by major axis length. Potential energy here is this much, kinetic energy. So you have to find the velocity. It's a, I think this is the easiest question from the paper, maybe, I'm not sure. Maybe this one. 2 point masses of mass 4m and m respectively by distance d are revolving under their gravitational attraction. Find the ratio of their kinetic energy. So omega will be same. By the time this performs on complete circle, this one also will be performing on complete circle, because center of mass won't be moving. So I can say kinetic energy of any guy is going to be half m into v square, v equals to r omega. Then you need to just take the ratio, and you know, if m1 r1 is the distance from this to m1 I have taken. For me, this mass is m1, this mass is 4m, m4. So this distance is r1, this distance is r4 I have taken, and m1 r1 should be equals to m4 r4 by the definition of center of mass itself. So answer should be ratio of r4 to r1. You know that should be in the ratio of mass, right? A cylindrical pipe which has no base, or there is only pipe, no base, of radius r and mass m is placed vertically on the horizontal floor. Two identical spheres, each of radius 3r/4 and mass m, are inserted in the cylinder as shown in the figure. At what minimum value of m/m will the arrangement topple? There is no friction between the spheres and the inner wall of the cylinder. So if you draw the free body diagram of cylinder plus masses together, so weights will be there, mg, and weight of the cylinder will be, I don't know where is it, center of mass. Now if you draw the free body diagram of only these two spheres, there will be extra force n and n coming into picture. Horizontal force will be coming into picture. So the meaning is this mg and this mg should be balanced by some external force which is from the ground, and as the pipe is in equilibrium in the vertical direction, this mg should be provided by the normal. And we can understand it when you try to take the torque about any point. You can see torque because of this force and this force will be getting cancelled if I talk about center of mass of the cylinder. So you can see this extra torque is coming into picture. So there is a tendency of toppling this way. So at the extreme case, normal will be shifting, and you know under critical condition this will be balanced by this, or anyway. So if you take torque about this point, torque is going to be 0 because of this force. Now torque because of this combination is going to be clockwise, that is 2mg minus mg is mg, and this distance is, And these values you can calculate because they said radius of the sphere is 3r by 4 and this total is r, so this is r by 4. So r plus r by 4, this is r by 4, this is also r by 4. So 5r by 4 into mg should be balanced by this opposing torque. This is 3r by 4 into mg, this is r into capital mg. From there you will be getting the answer. A rod with length 3l and insignificant mass is suspended in horizontal position by using two fibers attached to the ends of the rod. There are two masses m and 2m fixed to the rod, so their centers are placed in 1/3 and 2/3 of the length of the rod. Find the ratio of tension in the force in uncut string. In uncut string, this is what they were cutting and this one they are keeping. So they were asking what is the ratio of tensions in this string before and after cutting the string, which is close to 2m. So before cutting the string, there will be one tension, there will be one tension. This summation should be balancing 3mg. And if I want to find T2, I will take torque about this point so that I can avoid T1. Torque because of mg plus 2mg should be balanced by torque because of T2. From there you will be getting T2 value. Once you get T2 value, T1 value is easy to find because T2 plus T1 should be equals to 3mg. So this value is written wrong, it is 4mg by 3, 4mg by 3. Then only it is going to become 5mg by 3 plus 4mg by 3 is 3mg. Then after cutting, see, generally you should be careful about this because if you are taking torque about any point, then you may have to include torque due to pseudo force if it is accelerating. If you notice carefully, center of mass can go only vertically downwards because mg is there and tension is there, and about center of mass torque is going to be this way. So this particular point, if it is having an acceleration, that can be only acceleration of center of mass and acceleration about center of mass. So this particular point can't accelerate this way. So this point is not accelerating, so you can take torque about this point, so you don't have to involve pseudo force. When you take torque about this point, torque due to mg plus torque due to 2mg, that equals to I about this axis, which is ml square plus 2m into 2l whole square into alpha. From there you will be getting L alpha, but I want to find tension. If I want to find tension, I will write F equals to ma for the system. For that I have to find acceleration of center of mass. Center of mass will be somewhere here, which is at a distance L by 3 from here to L by 3 from here. So this total distance is 5L by 3. I need to calculate what is 5L by 3 alpha. 5L by 3 alpha I got. So this is the acceleration of center of mass of the system. So 3mg minus T dash should be equal to total mass into acceleration of center of mass. From there you will be getting T dash. You need to take the ratio of these two. It was written wrong, it is 4mg by 3. In the next question, in the demonstration of a stunt, two solid balls of equal density and radius r and 2r are placed with the center of the larger one above the middle of the cart, where cart mass is 6 kg and length is 3 meters. The mass of the smaller ball is 1 kg. If this is 1 kg, this is going to be 8 kg. Volumes are in the ratio 1:8. The balls are made to roll without slipping in such a way that the straight line connecting their centers remain at constant angle 53 degrees to the horizontal. The cart is pulled by a horizontal force. Find the time taken by the balls to fall off the edge of the cart in seconds. Now you need to understand F is not given, so we should be playing carefully with the equations maybe. I mean, if I write F equals to ma for the cart, that is going to look like this, but I know that is of no much use because this value was not given, and writing that equation is like bringing unnecessary variable. I can't bring that F anywhere. So this equation, though I write, it is of no use. So this cart equation is of no use. So we need to get the answer somehow. Now, and they said this is always moving this way only. I mean, their centers are always at an angle 53 degrees. So the meaning is this acceleration and this acceleration will be same. So if I take this as my system, I can say the only external force in this horizontal direction is friction, that equals to total mass times of acceleration. And apart from that, there is no slipping. So you can see if the cart is moving this way with acceleration capital A, so acceleration of center of mass and acceleration about center of mass should be equals to capital A for this point. That is this constraint. Acceleration of center of mass and acceleration about center of mass, this radius is 2r. Now as it is no slipping here, so 2r into alpha should be equals to r into beta. This is no slipping condition here, this is no slipping condition here. Then again, I want to avoid extra unknowns, I want to avoid the normal. So normal will be this way, so I am carefully writing F equals to ma along this direction. So mg's component mg's component minus friction equals to acceleration, mass times of acceleration component in this direction. Mg's component minus friction equals to acceleration's mass times of acceleration component in this direction. I am carefully writing it to avoid the normal. Similarly, I am writing torque equals to I alpha about this point. Torque due to pseudo force is going to become 0. Mg is going to become 0. Normal is going to become 0. Torque because of friction is going to be I into alpha. Alpha in the sense here it is beta. Similarly, I am writing equation for this also. So, torque due to this friction, that equals to I into alpha. So, I have written couple of equations and constraints. So, let me write all of them together. When I write all of them together, I will be getting these equations. These are the 4 equations and this is the constraints. Now, I know I have to talk about relative motion between the plank and the sphere. So, this acceleration is capital A, this acceleration is small a we assumed. So, I need to somehow find capital A minus small a, and I know it is not easy to find directly because capital A is involved in only other equation, which is this equation where capital F is coming into picture. So, I know I have to find it indirectly, so which is 2r alpha. So, somehow I have to find 2r alpha. For that, I am taking help of these two. I am taking help of these two to avoid A because I don't need A. I am taking help of these two to avoid A, and I am taking help of these two to avoid F. So, once I see this, I can understand, I know small f, I know this f as a function of alpha and I know this f as a function of alpha. Understand somewhere beta I would have substituted it as 2 alpha. So, I know everything as a function of alpha, this as a function of alpha, this as a function of alpha. When I substitute, I will be getting r alpha value, but I need 2r alpha value. 2r alpha is this much, the meaning is relative acceleration I know. Once I know relative acceleration, I can easily get the answer by looking into relative motion, right? Thank you.